I'm back again for another draft physics video production and such. Yeah, Bill Gaede's, I guess, we'll do some of. No comments on my videos to respond to, but anyway. Um, so he keeps pointing out somehow that no particle model, particles can't explain, particles can't do, particle, particle, particle. And again, you could replace the word particle with some idea of transferred momentum. Some idea of momentum moving from point A to point B, which is kind of rudimentary to the function of the universe. Kind of what we see in the real world is something has to. We don't see a lot of pulling. We see a lot of pushing, especially in our own activities. When we open a door, we push the doorknob. The doorknob is attached to the door comes along with the doorknob. But we're clearly pushing, not pulling on surfaces, even when we think we're pulling. And then there's all the overt pushing that takes place when things hit other things, like a volcano erupts and it throws a bunch of rocks in the air and the rocks push a hole in your house, that kind of stuff. Lots of pushing going on. Very little evidence that the universe is elementally made out of some sort of mechanism, ropes, whatever, tied to every object in the universe. When an asteroid hits, there's no evidence that any rope is pulling it in. So I'd say he has the higher burden of proof in terms of claiming the existence of the invisible, magical rope for which there's no method of detection. He has cited doing a couple of experiments that he thinks will prove something, and I've pointed out, like with his two-slit in a vacuum, his theory is wrong. And if they ever do the experiment, you'll see that it's wrong. That somehow light can't make it. Somehow it can't get to point A to point B in a vacuum, which is kind of hilarious. That somehow it needs atoms in its way. Doesn't make any sense at all. So anyway, I contacted Bill 6 years ago, whatever it was, trying to incite some sort of interaction, and he just doesn't seem to want to have that with me. I mean, he'll go on other people's channels and he'll do conversation, but he simply, I guess, won't do it with me for whatever reason. And he, again, doesn't really respond to any points you could possibly make about the elemental universe, in the sense that he doesn't care much about what your theory is, in the sense that he's not going to do enough or any work to understand it. Frankly, I can't say that universally. It seems like he did pay some attention to D. Hilster's theory, which is bad, flawed, and easy to pick apart, and so that might be why he chose it. And he's done some flat Earth videos, and the Electric Universe, he did some reasonable dissection in terms of figuring out that their basic premise that the magical electricity is doing everything, leaves a lot of questions unanswered, like all of them. About like every experiment ever conducted is not explained. But anyway. So, I mean, if I said overtly to you, there's no rope theory that can explain magnetism, there's no rope theory that can do this and do that, and I said that as some sort of honest argument, as if there was a bunch of rope theories. But anyway, I'm sure Bill would find that offensive, considering I've been watching his videos for 8 years or whatever the hell it is, and I'm sure he'd say, "Hey, what are you slighting me for? How come?" I mean, I have a rope theory that does those things. Now, I don't think his theory does do those things. I think his explanation of magnetism is ludicrous. A bunch of jumping ropes, spinning. It just doesn't. Sorry, it doesn't explain attraction or repulsion. How ropes banging into each other is a magnetic repulsion, and how they're hooking onto each other is somehow attraction, doesn't work for me at all. If I did that in real life with people jumping rope, it's not going to happen. It doesn't really seems like an awful lot of energy to create a tiny bit of repulsion and a tiny bit of attraction. So yeah, forget it. It's ain't gonna. There's no way the reality works that way, Bill. Wrong track, wrong road. Can't do it that way. But anyway, so I'm sure he'd be a little bit pissed. Like, what the hell? How can you say that crap? Okay, you know I exist. You know, how can you say that my theory doesn't do these things when I've overtly said it does these things? Yeah, and so I find it also a little bit offensive that this turd, okay, would sit there and claim he's seen every particle model or particles can't do something when sure they can. So two of his criticism, I'll play the video, play pieces of it anyway, jump around a little bit, whatever. I mean, he does repeat the same stuff over and over, so it shouldn't miss anything important. But two fundamental arguments I could say that he has made that are okay on the surface, they might make some sense. Well, this first one doesn't make much sense, but anyway. So it's his argument that a particle theory, okay, and he'll insult it by calling them Lesage. You know, he'll well, I don't need to write for you, or Casimir effect, which the Casimir effect is another experiment where it can be interpreted more than one way, in the sense that you put two plates next to each other and they attract. You know, even though you didn't charge them on purpose. But it could be understood that that's not a gravity effect. You know, that's not gravity that's pulling them together. That's charge that's pulling them together. Because electrons hate electrons, and electrons are on the outside of the atoms. And so one side does have to go positive. That is, the atoms have to compress, and one side will expand further because of the compression on the other side. So it's a process that all surfaces go through. It doesn't really have anything to do with gravity. So anyway, the idea is that he's arguing that somehow a theory of particles hitting something, and they hit it, this is very dense, okay, a high density of particles, and it's hitting a substance that we know theoretically is in fact more empty space than it is actual electrons and protons. So we know electrons and protons are inside of these atoms, but that there's a lot of nothing for the amount of something. And so basically what happens is not all of this stuff hits something. A lot of it just goes straight through, all right, without bothering hitting anything. And the curious fact, that's a fact, is that you can understand this mock gravity, it's called, theory, in understanding that this is what creates the proportionality of the force, is this very fact, that it doesn't matter the shape of the object, it doesn't matter the density of the object. I can make it really small, or I could make it very big in terms of the same number of atoms, right? I can put the same number of atoms in a small space or a big space, and this force, because of its density, will in fact just interact with the little bits, okay, just interact with the nuclear bits, and it will in fact proportionally apply force, in the sense that it will only block as much of this force, this energy coming from a direction, okay, as there is object mass inside the object. So it will always apply the force proportional to the mass. And so it doesn't matter what the object is, each object will get the same amount of force per nuclear bit. So the nuclear bits are the pieces that are moving when gravity moves something. And this is the reason why everything falls at the same rate. Everything does the 9.8 meters per second falling on the surface of the Earth. Now, a mile away it's a little less, and then it's 2 miles away it's a little less. But a little less. Something Ken Wheeler doesn't understand. But anyway, so there's nothing wrong with this theory, in the sense that you have this consistent force, you have an inconsistent amount of mass, but the mass itself is consistent. It's consistently electrons and protons, and it moves the electrons and protons the same, no matter whether they're in a clump. You know, whether I have the electron here all by itself, or I have it in this thing called a piece of matter, just doesn't matter to the electrons and protons. So in effect, the force just is pushing little bits, and it pushes them based on its density and the fact that these are consistent bits. So it just doesn't matter whether the bit... See, I could take an atom off the Earth and I could put it in space, and it's going to fall towards the sun exactly the same rate. I don't know, the gravity from the sun is something like 0.00014, where the Earth is. It's really small, so that's always something to keep in mind. Even though the sun is huge and all that kind of crap, where the Earth is, it's nothing like the surface of the Earth gravity. It's tiny minuscule fraction of that from the sun's gravity at the same location as the Earth. But anyway, that's not the point. The point is it's a nuclear force. It's just moving these little bits, and what form they're in is totally irrelevant. That's why the feather falls the same speed as the lead ball, and acquires the same amount of contact with the force, because the force just cares about these little bits. And obviously, if there's two little bits right next to each other, you can understand that the force can hit this bit, and this bit's going to hit this bit, and blah, 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 blah. So it all is in there. Okay, you can't avoid the contact. So it works fine. So his argument that somehow this doesn't work, and in the sense of there's obviously, if force is absorbed by these little bits, and the simple argument is this is really just about speed. You could understand that the force bits are moving the speed of light. The matter bit is now going to take over for that. The speed of light stuff is going to get stuck in this matter bit. The matter bit's going to move much slower than the speed of light. And so this force that was here, it should have been here, and it's stuck back here. And so it's not getting to this object, and that means there's going to be more force on this object this way than this way, and it's going to move this object that way, because it's going to end up absorbing more, because more stuff is hitting it. It's going to absorb more, and there's not going to be a balance anymore, and the imbalance is going to be in the direction of the thing that blocked the speed of light energy, that absorbed it, is occupying it, is slowing it down by keeping it inside a little matter bit. It's moving much slower. And the principle's simple. That creates a low pressure. That creates the effect of the objects moving towards each other as if they were pulled, but they're not being pulled. They're clearly being pushed, okay, by the counter force that always existed, and you're just depriving it of what it was supposed to get hit by. So it works fine. All right. So another argument of his, which, like I said, is valid against the Hilster, because he doesn't explain anything, so he doesn't explain where the energy goes or how it gets out. So the idea is that there's thermal equilibrium. So if you were blocking forces, the force would have to come out somewhere. So let's say this object now is moving in this direction because it blocked the force and is now moving this way, right? And so that's towards the sun, let's just suppose. The problem is that, well, where to go? Where's the energy? So in a sense, if this is at some state of equilibrium, which everything gets to, then it has to admit whatever it took in. So whatever goes in has to come out, is the sort of the argument. All right, so there can never be any way you could absorb this stuff without pushing. So as much as you're creating this effect, it can't be a permanent effect, because you'd end up pushing eventually anyway, so it can't work. Is that when something's gravitationally affected, it isn't like velocity of wrenches thrown in space or something. The velocity something gets is not some sort of permanent velocity on the nuclear level. As pointed out, electrons can't maintain their velocity through space, because there is stuff in space. And as they move faster in a direction, they hit more of that stuff, and that stuff essentially grinds them back to a neutral again. Takes the imbalance that was inside of them and destroys it over a period of time. So when stuff is inside of, let's say you're standing on the earth, okay, you're just sitting there standing on the earth, and you're gravitationally getting pushed down, the thing you're not seeing is that you are denting the earth, that there is a constant acceleration. Even though you're not moving, okay, you're not gaining any velocity, you are constantly being accelerated, which means there's parts of you, right here, for example, this little atom is moving this way because of the gravity, and this little atom is moving this way because of the gravity, and this little bit's moving this way because of the gravity. And at the same time, the earth is pushing back up, so this little bit's moving this way, and this little bit's moving this way, and this little bit's moving this way. And the two forces are balanced. That's why you find a position. You dent it a little, the pressure becomes equalized, and that's where you stay, in the equalized pressure. And so while you're in this field, you're not as static as you look. There's a lot going on inside of you. And the same is true for the earth out here. What's happening to the earth is that parts of it are going towards the sun, and other parts of it are going away from the sun. It's swirling in here. Okay, there's a bunch of energy, turns in vectors happening all the time. And all of this is active. It isn't like, it's not like an orbit. Okay, what's inside the earth isn't like something came out here and it got into an orbit. Nothing does that anyway. Nothing comes from the outside with gravity and falls right into an orbit. It has to hit something, okay, to slow it down, and then it can be in an orbit. But it can't just come from outside and go into an orbit. It has to go right into the, crash right into the center, okay, or it has to miss. And if it doesn't do something, if it doesn't interact, it doesn't stay. Just a fun fact. But we don't need all that in this drawing. So you have to understand that the Earth is the little bits, the little nuclear bits inside, the little electrons and protons have to be constantly maintained. To maintain a velocity, they have to be constantly fed the force to do so, as pointed out, because it'll always balance out. They'll be dragged to ceasing to move. So the very fact that the inside of the Earth is hot, that is, it's all swirling and hot, it's hot because of this fact, because parts of it are moving in different directions. That's what's melting the center of the Earth, is gravity. Now, if you have some other explanation for why the center of the Earth is melted, fine, let's hear it. But it's gravity that's doing it. And so it's actively making these exchanges. And so the truth is that when you block the force, this way, that's going to make this person sitting here end up being gravitational, because he's not getting hit by a force in one direction. And likewise, the guy on this side, if you block the force, this stuff is blocking a force that would have hit him. It's not hitting him now, and so he's being pushed this way, because there's more stuff here than there is in here pushing the other way, because it didn't get through here. The force out here in the space and the force out here in space were equal until this thing showed up and made this possible. But I'm just saying, this stuff in here is what showed up for these people on the surface of the Earth. This is irrelevant now, the sun. We're just talking about Earth gravity. What's relevant to the people on the Earth is the fact that this big ball of stuff is blocking force that would have hit this guy on his feet. And so the same amount of rain's coming this way, the same amount of rain isn't getting through this huge umbrella, you could argue. And so the person gets a decided push in one direction, and the one direction is into the surface of the Earth until the pressure is equalized, until there's enough of this energy pushing the other way to push him back. But the point is he now starts to swirl. The same thing is happening inside of him. pushed down by one force, pushed up by another force. But the point is that if you think a little deeper, you can understand sort of what the consequence of this occupation of a force. So the force, basically, you're saying if there's a force coming in a direction, you put an obstacle in the way, the force doesn't get where it's going, which was here. This is where the counter force is over here. So these two forces aren't balanced because one force is trapped in here, swirling around. The simple argument. The thing to understand about that is the fact that this force got blocked here means not only that it didn't get to this surface, but that it didn't do the very thing Bill Gaede would say it would do, which is get the rebound, which is it went in and there's always going to be an out. Well, it didn't get the out, and so the out arrow that also would push against this thing also doesn't exist. You can't have the equal but opposite reaction if you didn't have the action. So the action's stuck in a trap, delayed here, moving stuff. It doesn't get here. There can't be any reaction, which would be the reaction would be the I'm going to hit and throw it back at you eventually. So you're lacking the repulsion that would have been the consequence of this not being blocked. Would have been the fact that this arrow, after a period of time, would have ended up here. And that's not going to happen. So you've, in a sense, killed two effects. You've killed this effect, pushing this away, the hit here. You got rid of this interaction. You also got rid of this interaction. So that explains why this low pressure becomes a real low pressure, is because you're stopping this action that would have been part of the process. By absorbing it here, delaying it here, means you stopped all of that from happening, and that would have been part of what would have balanced your condition, and it's not there. And so all the other stuff is still happening, caused by this force pushing. Don't know if I need to go any further than that on this. So it's clearly understandable. It's a little bit complicated to understand, but the basic premise is kind of easy. This goes into the matter. The matter moves slower because it traps the energy. Alright? So it's going the speed of light here. Now it's going a lot slower. Alright, and it doesn't get here, just quite obviously in the same time frame that it should to counter this force. So it's just not there to counter it. And we see the effect of this constant absorption. That is, moving these objects requires you to keep pumping the energy in, to keep moving the electrons. For me to move the electron this way, and then for the electron to move back this way, to do that, you have to keep pumping energy in to have that happen. And that's what's keeping the Chinaman on his Earth, and that's what's keeping me on my Earth, is the fact that both directions are absorbing energy. In both directions, energy is being caught in these traps, which is the movement of matter in a much slower than it would have gone. So the gravity you fall into, in essence, is not the gravity you're creating by blocking. The gravity you fall into is the gravity being created by this stuff moving this way. If it's moving this way, then it's absorbed force, and that force didn't get to you. So that's the simple argument. And it's not overtly flawed as Bill Gaede would argue. Now, of course, Lesage and Fadio, and he brings up some guy from the 1600s, which wasn't exactly the same, Decenti or something. They didn't know nuclear physics. They could, there's no way they could have defended the argument with this understanding that electrons and protons need to be constantly accelerated if they're going to keep moving. They're not wrenches you can just throw into space. Atoms can do that because atoms can have motors, okay, motors that keep them going. But single electrons and protons can't do that. That's why we don't have something called a weapon, an electron gun. We can't go on the battlefield and shoot electrons at somebody, you know, because they won't work. They won't do what you want them to do. They'll lose their velocity to the atmosphere, even if you were in empty space. They just won't cooperate. They'll slow down and stop. That's why you don't shoot them to the moon and bounce them off. Electrons just don't do it, and protons don't do it. Well, yeah, that's enough. You don't need to keep reiterating it. The nuclear physics is a little more complicated. It's really not complicated. It's just you have to understand the difference between the elemental bits and how the elemental universe works and its rules, and then the emergent rules that come out of when you compound the elemental bits. You know, when you combine them in relationship to each other, you can create new functions. All right, so let's play some of this crap.
Right, so they're separated and they have charges, and now we can have electricity, and we have the electric beads, electron beads flowing from atom to atom, and now we have electricity, and we have connection between stars, galaxies, and whatever.
Yeah, so charge is just a consequence of understanding that the electron and the proton are different for some reason. And the reason can't be, if you want to explain magnetism, the reason can't be because they just react with a single force differently. All right, if you just made electrons and protons, and you say, okay, we know these two things are different. Now, they have to create something, you know, let's just put them opposite each other for the sake of making the magnetic argument. So we know that there's going to be attraction, you know, between the electrons and the protons, and we know there's repulsion between the electron and the electron and the proton and the proton. And the trick is, how do I do that with one particle that's going to be bouncing between them? So with reflections alone. Now, obviously, reflections alone will work this way. You know, you could just have stuff bounced. Okay, they reflect, black, and the force reflects. But I can't do that with with protons too, with the same thing, because now they're not going to be different. So I can't have them reflect the same force. They would have to somehow deflect that force, okay, or let it pass right through them, you know, without effect. And that'll get me, so if I let them pass right through the protons without effect, I've solved part of the problem. But then how does the same force go through an electron? See, you know, that's the problem. How do I make the same force do two different things? Because we know these electrons are the same, and they don't have some kind of condition like I'm on or I'm off as an electron. They're always on. They always do the same thing. So how can I make the same force do that? So in the sense, if you just understand, oh, well, just as there's two charges, there's two kinds of little bits, you know, moving the speed of light. You know, there's a red one and a black one. So yes, the black ones reflect, and the red ones reflect off red ones, and they do the inverse. The red ones deflect the black ones, and the black one deflects the red ones. And now you have what you need, which is you have the protons being repulsive to each other, you have the electrons repulsive to each other, and you have electrons and protons attract each other in appearance anyway. Just by doing this to the particles. And then you really understand what charge is, you understand how it works, and how batteries work, and how magnets work. And you understand that these really are the monopoles of magnetism. Well, I did them the wrong color, but you get the idea. This is a magnet. A proton and an electron close to each other is a magnet. It's a dipole. It'll function just like a magnet. If you tested it with another dipole, it would do exactly what magnets do in terms of the force effects.
That's the notion they want to convey. So it is a particle theory. The electric universe has borrowed their atom from mainstream science. Flat earthers, particle theory. It's a particle theory. You know, whether they talk about the dark energy pushing the earth from below, or whatever other thing they want to explain. I mean, they're going to explain light. They're just going to fall back on, you know, James Maxwell, on any of these folks.
Well, they're not really particle. I mean, to say they're particle theories when, in essence, some of these theories are saying, like you, they're just creating some new element. And so the new element is either a really short rubber band, okay, like compressible space. It's some sort of piece of rubber in space. And the piece of rubber in space can be contracted or it can expand. And that's what they're sort of doing to it. But I mean, the problem with that is they really don't explain how it expands just in one direction, you know, like a photon does. Like, how does the rubber know I'm not supposed to expand in every direction? And then other times they want it to expand in every direction because they want it to have some field effects everywhere. So if I had this rubber, a bunch of little rubber cubes, you can sort of understand if I squeeze one of the cubes, it would squeeze in all directions, almost like creating an Einstein well kind of idea. But we know photons aren't doing that. They're not leaving some, you know, field effect as they travel somewhere. They're not moving a field in any directions that could ever be detected. So they clearly don't have that effect. They're just moving, the compression is just moving in a straight line by all appearances. But anyway, you wouldn't call those particles, I don't think. Okay, if they have rubber band capacity. Just as your rope theory, you're saying, well, I can make rope without using particles. Well, you've just made the particle really long, haven't you? I mean, what's the difference between having the little piece of rubber and then you're just saying, no, it's one long piece of rubber and it just has this tension in it, this torsion created by some magical energy that doesn't come from anywhere. So somehow your sun is grinding tension into all these ropes. You know, somehow it's twisting all the ropes, making them shorter and shorter, so everything moves towards it. Where's all this grinding energy come from? At least Mach gravity, you know, this particle theory, explains where the energy comes from. You can follow the energy through the cycle. You can see that it goes in, it gets stuck inside the little object, and then the little object moves slower because there's a lot of stuff to move. Okay, so that makes sense. If I hit with a big lead ball with a cue ball, I understand that I'm not going to get the lead ball to move as fast as the little cue ball was moving, right, on a pool table. The lead ball is going to move much, 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 much slower. And the same kind of argument goes. So your theory doesn't explain any of that. It doesn't explain where the energy comes from and you know, how you account for it later. You know, you don't account for it, all its effects. So there's no chain. You're missing links in the chain of reasoning because your energy source is missing. Where'd it come from? I'm saying everything that's moving in the universe is moving for a reason. Every piece of matter you see in the universe moving in some direction means it was in an imbalance somewhere that loaded it with that imbalance. The electrons and protons are in fact moving decidedly in one direction more than the other direction because of their arrangement, and it stored the energy. It took it from some other location. Little bits jumped in that boat, and they haven't left the boat yet.
And all these people that were etherists, meaning they were particle theorists. There's never been another proposal in the last 10,000 years except particles.
Well, I don't think anybody had, I don't know why they would imagine ropes from every atom to every atom. And when we know that atoms aren't made out of, atoms are composites. So, you know, theoretically your ropes have to go from every electron to every electron and proton in the universe, theoretically. So if you're going to deny the existence of electrons and protons, well, that's a bold step. It requires a lot of argument to explain that one. So I mean, but no, who would propose something as ludicrous when we know that you know the apple is to the earth what the what the atom is to the apple. You know, how can I imagine every bit of the earth, even every clump of earth the size of an apple, even being connected to every other earth clump of apple? I can't even imagine that making any sense with a rope, let alone expanding it to the atomic scale and trying to imagine how every atom could be attached to every other atom. You have more rope in the universe then than you have stuff in the universe. And that just doesn't make any sense at all to me. It's inconceivably bizarre.
Okay, and that's where the thing changes. Okay, here I put this little thing here, and now we can see what's happened in general terms, just a big picture. The Greeks, they talked about particles. They invented the ether, essentially, right? And they saw it.
So again, he's calling ether particles, and I don't think they envisioned that as particles. I don't think they knew that water, okay, was made out of atoms, and the atoms were essentially in tension because of chemistry, because they had some molecular bonds, not terribly strong but not weak at all either, creating tension. So when you move one water molecule, you drag the other molecules along with you. They didn't have any notion of that. So I don't think they thought mediums like air or like water were made out of a bunch of little particles all jiggling in space. So I think it's really unfair to say the original ether theories, or even some current ones, have any notion of particulizing the ether. Now, a lot of people do. Franklin Hugh seems to particulize his ether, which I think just breaks the geometry. But yeah, I don't know. They just don't go that step deeper. They think that there's something elemental about water or air, that somehow it's just a consistent medium that has this bizarre capacity to perturbate something through it or something. I don't know exactly what they think, but it obviously doesn't work. It obviously isn't elemental enough to be the right answer to say the word ether. It doesn't say enough, so you do have to say something more about how the hell the damn shit works.
There's a bunch of particles out there. Some of them were in space. Some of them were here on Earth. They simply visualized this as a world of particles. And they had no good idea of what they were talking about, but they theorized this was the starting point.
So again, yes, and the whole point is if you do that, you turn it into particles. Let's say you're an etherist and you believe in the particle theory, and this idea that they're jiggling, well, that wouldn't make much sense, frankly. But the idea that they have motion does, that they're creating pressure. So if you just give each one of those little dots a different vector that it's moving in, you'll end up with something called pressure around everything in there. And now you can change the pressure. So a simple argument I would make about people who have pressure theories, like Ken Wheeler, for example, uses words like pressure mediation. The universe is pressure mediation. You have to explain where the pressure comes from. You can't just say there's spots in space, because that doesn't create pressure. But if all the little spots are BBs and they're all moving in a vector, then you have pressure on everything. Everything's getting hit by the BBs. Everything's pressurized. So you have to have pressure, high pressure, before you can mediate pressure. You can't start with zero pressure and say, I'm going to mediate the pressure. You have no pressure to mediate. So first you have to create the high pressure before you can mediate the pressure.
This was normal for, when people start for the first time to look at physics, and they say, well, how does this work and how is that and so on. Well, they started with particles. In fact, Democritus, the first guy there on the upper left, he was a particle theorist. He came up with the atom. Or either him or Leucippus, his professor, one of those two came up with that. But Democritus is credited with the atom, right? And all these people were talking about the ether. They were talking about atoms. They were talking about particles. Well, that lasted all the way to the 16th and all the way to the
It's certainly something you can understand in the sense that we see it. We see that a beach is made out of a little grains of sand. We see a lot of things that are made out of subdividable pieces, and it's clearly sensible to start speculating about, well, what if I cut it even smaller? What if I cut it even smaller? Now, it's some of that's quite logical. When Ken Wheeler does that, for example, though, it becomes illogical because he says you can cut magnets in half and a half and half and half, and he doesn't understand that there's a point you reach where you're not cutting, you're cutting atoms now. And when you cut an atom in half, you are separating electrons from protons, and you are in fact creating monopoles.
17th century and all the way to the 19th century, because all these other folks, Galileo all the way to Hertz, all these folks dealt with ether, and they just kind of fueled the ether. They all were talking about.
Yes, well, look, to sit there and rehash the history, it seems so irrelevant to the real argument. We know that they were ignorant in the past and they couldn't make developed arguments. So we know Darwin's grandfather believed in evolution. He believed we evolved. He couldn't prove it. It was just his hunch. Okay, I mean, he looked at the world and he said, yeah, look, we're screwing with stuff, we're changing what it looks like, we modify, everything gets modified. If my wife looks a certain way, my kids are going to look a certain way. We knew that. It wasn't that complicated or hard to figure out, this idea that heredity happened. And you just understand that, yes, if you have a competition, things will survive and things won't survive, and they're going to look a certain way because of that. We know that even in gladiator fighting, the swords were a certain length. Everything ended up being perfect to the job that had to be done. Everybody modified their battle gear to the war they were fighting, and there was purpose and reasoning behind how your shield was shaped, how everything was done based on the weapons you were using, and how easily you could move the both of them. I mean, it was all conditioned to the purpose, and so the idea of it could be understood. It just couldn't be argued very well, okay, because they didn't have enough details. They didn't have all the little bird beaks, and they didn't have the tortoise shells, and they didn't have all the fucking evidence, the volumes of evidence. And they didn't compile it, and they didn't do all that stuff. So again, this is just such a useless argument to sit there and say they believed in particles. Yeah, okay, maybe they believed in them for the wrong reasons, okay, in the sense that they believed for some intuitive reason, some just sensible reason, commonsensical kind of reasoning, rather than some elaborate reasoning that accounts for all the basic differences between electrons, protons, and then atoms and how they function differently. Yeah, they couldn't account for all those differences. It's just silly to argue with the the ancient archaic argument. So it's like somebody saying, I'm going to argue with Darwin's grandfather rather than Darwin, right? If you're going to argue evolution, you argue with the guy who has the evidence, not the guy who didn't have the evidence. I mean, this arguing with dead people is such a bullshit tactic.
The ether. What was the ether? A bunch of particles. And they modeled all their theories based on the ether. And the ether died in the dawn of the 20th century, right? With Einstein and
it clearly didn't die. I mean, Einstein's bent space is bent something. It's not bent nothing. Space was a word for nothing, a vacuum. It wasn't a word for some bent geodesic. So Einstein didn't change ether except to change what we call the ether. So now instead of calling the ether, they're calling it bent space-time. But it's clearly ether theory. It's energy from nowhere.
And I'm putting only a few people here. We have several people there. We have Niels Bohr and Feynman later on and so on. And these people abandoned what? What did they abandon? They abandoned the particle. See, up to the end of the 19th century, people were thinking in terms of particles. They said, oh, particles this, particles that, the ether. What were they vibrating?
Well, again, I don't think you can put Einstein in that category explicitly. His theory was basically he fought for a deeper understanding of quantum mechanics in the sense of elemental mechanics. He believed there was a unifying elemental mechanics, so let's not pretend that he wasn't seeking something. He wasn't asserting as much as he was seeking, to his credit, where the rest of them stopped seeking. All right, so if you want to ridicule Feynman, and Feynman overtly stopped seeking. I mean, he basically said, I'm really smart, I can't figure it out, therefore you should forget about trying to figure it out, so just do what we know works and forget about understanding why it works. Okay, why it works isn't an important question. The fact that it works is all that we need to know. All we need to know is that light is bent. Okay, so that's the part we know. That's quantum mechanics. Light is bent. Why is it bent? Let's just make up a story. It doesn't matter what story you believe. Copenhagen, this, where, who cares? I don't even want to know about your silly explanations. All of them are shit. Forget about thinking about it. That's what Feynman said. So again, these are, this pigeonholing. He's just pigeonholing all these people and throwing them in the same category. I mean, Huygens and Newton in the same category is complete bullshit. Obviously, they didn't agree. Newton wasn't convinced by wave theory.
They were vibrating particles. In the 20th century, that died. The real particle is what died. It died especially with quantum mechanics. What does that mean that it died? It means that they could not explain. They could not explain what real particles.
They instead created ones that are synthetic. And why are they synthetic particles? So you could argue that they're a concept of a virtual particle being the force carrier. The fact that they knew photons were somehow involved, and they had a notion that these photons were things, not perturbations, that traveled distances, that went from point A to point B as a something, not a nothing. But clearly they couldn't account for its origin. Where did the energy come from? Where did the damn shit come from? They couldn't account for it, so they have to call it a virtual photon. They also can't account for it doing two different things, causing repulsion and attraction, going through the object and hitting the object. They can't account for how it can do that with the same thing. So that's why they call it virtual. But they only call it virtual because it doesn't work in their model. Their model's broke. That's why they have to call it virtual. But they were on the right track in the sense that everything else was right about the idea that the reason why electrons are repulsive isn't because bent space. It isn't because of some magical thing. It's because there's actual energy, momentum moving between the two objects, pushing them away. There's an actual ping pong ball between the two paddles that keeps bouncing back and forth between them. And as I put them closer together, I create more energy just by proximity. I create more interactions. That part is absolutely correct.
Could not explain how this universe works. They cannot explain simple things. In fact, to this day, they cannot explain.
Nobody explained magnetism. You don't. Jumping rope bullshit doesn't explain attraction, strong retraction, strong repulsion at all. It's totally inconsistent with Maxwell's math and drawings. It's so mushy an explanation. The clear explanation is Maxwell was correct in the sense that Maxwell drew you a simple explanation of what the force is actually doing. Okay, its effects. He gave you two examples. He gave you the effect, and he gave you the cause. All right. So the cause is in the simple diagram of a charge. The charge radiates a force. All right, and it is this that is the inverse square law. The force is separating, diverging in two directions. If I radiate something, I radiate it in two different, it separates with distance in two directions, this way and this way. That is the frickin' square, that's the inverse square law. So this is what a charge is doing. This is the drawing. You just want to know how much the charge is going to affect you. You just draw your object and you say how much of this force hits me. The closer I am, the more of the force will hit me. Two little things hit me, right? And there's an infinite number of lines that can be drawn here, so just understand that. Okay, so this object gets hit with 3 lines, this object gets hit with 10 lines. Okay, that kind of thing. The closer you are, the more lines you break, the more force you're affected by. And then he gave you the field lines, were just drawing where it's all equal. You just say where's the same altitude. So it's just an altitude map. It just shows you a way of seeing the charge, okay, topographically. So you can understand that the object is radiating, and then you can understand, I could draw this picture for a light bulb. The light bulb is radiating photons, and it's exactly the inverse square law again. Just as this hand does the same thing, okay? I move it half the distance, it's 4 times bigger. Not twice as big, 4 times bigger. Light bulb's doing the same thing in 3 dimensions, okay? And Maxwell drew you a line, just saying, look, this is where it's all hitting 3s. This is a 3 force here, and here's a 3, and here's a 3, and here's a 3. These are field lines, but nothing's traveling these lines. Nothing's moving around these lines. Nothing's happening. This is just an artificial line, where these are the real lines of force. Where is your model consistent with that, I think, well-established fact?
And what happened? Maybe I should put that back up. What happened in the 21st century? We had a paradigm shift. Okay, what was that paradigm shift? For the first time, we have pull. See, with particles, you can only
I
push.
absolutely hate this word paradigm shift. It's just such a pile of crap. But clearly, Einstein being able to get away with a silly explanation, bent space time, and then doing the whole Eddington fraud of basically saying, here, we're going to confirm Einstein based on a marginal experiment conducted in a marginal way. It's just silly. I mean, I watched an Einstein documentary. I haven't finished it because it's so bad. Made by PBS, Einstein it's called, movie. And it's just horrible. I mean, it's so full of overt, not truisms. I mean, the whole thing is just the not true story of Einstein. I mean, there's not a single fact they got right. Just so bad. I mean, this is what they do to history. They just fableize everything. Everything gets turned into some perversion. It's a redundancy, but you get my point.
You got to go out of your way to figure out how you're going to be pushing to produce pull. Okay, that was the issue. And now
the issue is that if we look at all our pulls, they're all pushes. So that's the issue you're missing, the obvious one, where you can't put your rope around your donkey's neck and pull on your donkey without pushing on the back of the neck of the donkey. You're not pulling the donkey, you're pushing the donkey, and it's always an inverted push.
We have the age of pull because now we have something between the atoms that is elongated and which physically interconnects them. So that's what's changed at the dawn of the 21st century. So we have a new paradigm. Okay? There's a new kid in town, and that kid is the rope. The rope binds any two atoms, and now we can explain pull. We can show you a movie of pull, okay? And we do that by aggregation, by having the ropes fan out. That's for gravity. But we also can explain magnetism, how two magnets come together, all mechanically, physically. And you can't
ropes spreading out how? The two objects, it's not like the two objects were together at some point and then you pulled the ropes out and they spread out or something. Somehow this all has to work in some other way, this rope. And again, it like I said, it doesn't explain so many things. So many things are left just, well, there's no reason why they don't get tangled, but somehow they do get tangled because you need them to get tangled for magnets to work. You need the ropes to hit each other in some meaningful way. It doesn't make any sense. So one minute your ropes are solid, the next minute they're translucent and travel through each other. And the next minute they need to hit each other for something to happen. I mean, there's no consistency to these ropes. They do whatever you want depending on the subject you're attempting to explain.
Do that with particles, and that's a little bit of what I'm going to be talking about today. In fact, one of the big problems that they have is that with particles is that they have to cheat constantly. Here's the atom, just as an example, right? Here's the atom, the quantum atom, and it's got these.
So they cheat any more than you cheat. So again, this argument that somehow he's less cheating us with his explanation when his explanation of magnetism is a huge frickin' cheat. Doesn't explain anything. Again, two ropes hitting each other. How does that explain the intense attraction between magnets, of opposite polarity? Doesn't.
Quarks, red, blue, and green quarks. And
all right, well, let's skip this because, again, he's just arguing crap that, yeah, I would argue is nonsense.
Say, well, we haven't discovered it yet. We're still searching. And the gluon, it's too tiny, but right now they illustrate it as a little bed spring. You see, what's this bed spring? Are you saying that the quarks are connected? See, because if you do it with particles,
so let's understand that all of these things that they claim to exist only exist. They never saw a quark. They never saw any of this stuff. What they did was they took two electrons or two protons or two somethings, and they smashed them together, two complex hunks of matter, and they smashed them into each other, at very high velocities. Now, at very high velocities, I would argue there's not much of the original thing left. Okay, the original thing starts off with stuff going in all kinds of directions, right? And you're basically just changing its bias. By giving it momentum, you're saying, okay, more of these things are going to be going this way, okay, than any other way. And sort of the point would be is once you do this fast enough, okay, once I take the boat and I move it fast enough, I throw enough force into it, what I'm going to do is I'm going to leave this behind and this one behind, and so all the rowers in the boat, as you start going faster and faster, you start leaving all of these guys that are rowing in any other direction. They get left behind. That part of the pattern is lost. And so you just end up with really a bunch of rowers. Just a big pile of them all condensed in one location as a force. And then you're banging forces into forces, essentially. And you get stuff fly out of that collision. Okay, the few that you have left, you go in any other way, they get released, and then you call that whatever, a gluon or some other poopy particle. But it's really not a particle, it's just force moving in a direction. We really can't tell the difference. Okay, so if I took an asteroid and I broke it into 400 million little pieces, all right, and I hit your house with it, it's the same thing as if I have the solid meteorite, right? You can sort of get it. If I break it into a bunch of pieces, it's going to look the same. The hole in your house is going to be the same. It's not going to make any difference if I do it atomically or I do it, as one big meteor. It's the same difference. So the force is the thing with the power. The force is the thing that can break the atoms and smash the electrons and the protons. So, move the boat too fast, break the boat by hitting it with too big a wave. Whatever metaphor you want to use. But that's all these extra particles are. They just see force. They can't tell whether the asteroid was one big clump or a bunch of little rocks.
Quark should fly away. You should throw at the, when Quark throws a gluon at it or a bunch of gluons at another.
I shouldn't say they can't tell, because the obvious giveaway, okay, is in the very fact that the thing doesn't have any capacity to survive, that the thing that hits doesn't have any clumpness to it. It doesn't go somewhere else as a solid thing. It disappears as a solid thing. It breaks into a bunch of little tiny fragmenty pieces. And that sort of gives you the indication it's more likely that it was little pieces to come in, and that's why it's little pieces going out. The fact that these things only survive for a millisecond, less than that, sort of tells you they're not elemental boats. They're just pieces of a boat.
Quark should kick it away, right? You would suppose that's the case. So they had to put the bed spring to show that they're kind of bound together. But that's cheating, because that's not what quantum mechanics says. And again, the reason they can't.
Well, again, your rubber bands are cheating too. You're cheating the same way. You're sitting there saying that this rope is pulling. Well, why? Because it's turning. You're twisting the rope and making it tighter and tighter, or what's the mechanism? And I want to argue whatever your mechanism is, you haven't accounted for where the energy came from. There's no fuel to fuel your mechanism. He has no fuel for the magnet. He says the ropes are jumping. He has no arms to turn them with. He has no mechanism. He just says it happens perpetually. That perpetually the magnet's creating all of this energy. I'm arguing simply that no, the magnet's just filtering what's coming in. It's completely passive. It doesn't contribute any energy to the function. It's just a filter.
I explain gravity is for the same reason. Gravity is a pull force. Whether you like it or not, it's a pull force. And people have to go away with these Ptolemaic explanations to try to push.
Right. So again, he's classifying all the theories and saying he has knowledge of them, and he's capable of pointing out some flaw they all have, which isn't true. I will argue that, yes, other people's explanation, even a Darwinian explanation of evolution, is a little weak. Okay, it has points where Darwin says, I don't know how it happens. I don't know how this hereditary thing, what it is exactly inside of us that gets exchanged, but clearly some kernel of information is being exchanged. And that's all he could say, because he couldn't say anymore, because he didn't know what a fucking DNA molecule was. All right? But, Bill's claiming that he's found some fundamental flaws. No, there's no fundamental flaws. There's just flaws in their ability to defend their theories, because they haven't thought about it enough, or they haven't gone deep enough to be able to do it, or they just don't have the information like Darwin. All right? But the theory's not wrong. It's just that they don't have enough pieces to give you an answer to those questions, just as you don't answer some questions. So you're just such a hypocrite to say, I'm gonna crucify them for the questions they didn't answer well, when you have lots of questions you don't answer well.
Package push in a way that you can see as pull. That's what they're doing. And those who tackle the problem, have to go out of their way. They end up with all these column-make solutions. We're going to go over that in a second here. Okay.
Yeah, you don't need anything. Like I said, it's not that 2 + 2 + 2 physics. 2 types of force, 2 types of matter, 2 types of interaction. That's it. Not complicated.
So let's summarize what the problems with the particles are. Particles in relation to gravity, which is where we left off the other day. Okay, I just want to rehash a couple of those issues. Okay,
so if I was to title put a thing up on my video saying particle ropes cannot rationally explain : and maybe I'll put a picture of Bill Gaede's, right, because he's the only one I know who has a rope theory actually. And I'll just say they didn't do it. He never made an explanation, never had an explanation. Not that I debunked them.
Is well within your brain why, like this fellow said, I'll put that up again so you know what the...
So he says mechanism for gravity. Now, obviously it's called mock gravity, so you don't just say Lesage and you don't say Casimir effect. You say mock gravity, and then you explain how mock gravity doesn't work. And the only reason why mock gravity failed as a theory is because they couldn't account for this velocity problem. That's the fundamental argument. And also they didn't understand that the gravity I'm falling into, I'm not causing that gravity. That's what I'm causing to something above me. Something above me, I'm adding to the Earth's mass, therefore something above me is going to feel a little bit more gravity. So I'm changing the universe for somebody else. The ground below me is what changed the universe for me. So I'm falling into the crust gravity. I'm not falling into the gravity I'm creating. The gravity I'm creating is somebody else's problem.
The issue that this fellow raises, could they just go through atoms effectively, push the atoms by interacting only with a nuclear part, like saying, it's not going to, interact with the electron? Again, people are...
Yes, that's exactly what it is going to... So we didn't even quite read that comment correctly, in the sense that, yes, it's acting on the nuclear bits. There's very few nuclear bits inside what we call the atom, so clearly the gravity could go through the atom without hitting any of the nuclear bits in the atom. But it will hit the ones that are in the atom. It will hit those. And it will give those bits momentum. And to give them momentum, it means it's not going where it was going. Clearly.
Trying to look for ways to fit particles in one way or another.
Let's understand, it's not going where it was going at the same speed. It's getting there slowly. So if the moon was to slow down and actually start to fall towards the Earth, we'd certainly understand this is going to be a big problem, because all of that energy, all of that acceleration is still in the moon. It has a ton of force pointed in our direction inside of it. All of its little bits are going to be moving towards us for a reason, because they have rowers in their boat heading right for us. All right, and that's real force that's still in the moon. That's whatever the gravity is for the moon from the Earth, which is probably 0.05 or whatever, meters per second for years and years. It has years worth of energy that is going to arrive at the Earth when the moon finally gets here. And that's going to cause one hell of a interaction. Lots of boats, lots of swimmers jumping into boats.
They don't realize we're not talking first about real particles, and second, quantum has abandoned the particle, the real particle. Quantum doesn't do particles. Doesn't do quantums anymore.
Well, look, there's no point in calling conventional physics a particle model when it has absolutely nothing resembling particles. Everything they talk about is this stupid Schrodinger wave equation bullshit. They've waved everything. They've turned everything into some vibration in some medium, or some dimple in the medium, some depression in the medium. So to call it a particle theory is just a lie. Okay, so they lie and then you enforce their lie. They disguise it as a particle theory for whatever reason. They dress it up as if they're doing particle theory, or particle physics, when absolutely none of it has anything to do with particles. You know it, so why are you pretending you don't know the truth?
The quantum today is a concept, an abstract concept, which they can describe mathematically, but not one that they can give you a pictorial representation of, because it's a concept. You can't replace love. You can replace.
Okay, so again, this he's getting into a stupid verbiage argument. Concepts are fine. Concepts like running is a concept. Yes, it's fine. There's no reason why we can't have concepts.
Love with the heart and say, well, the heart represents love, but is the heart the same thing as love? No, it's an analogy. Analogy for what? I mean, you're using an object to represent a concept.
It's not exactly as egregious as that. So again, it's more nonsense. They're obviously using it as they'll use any kind of word to describe what they're basically talking about, which is the movement of momentum. Okay, it's momentum that's being moved from one point to another point. Maybe everybody could agree with that argument, that we're really just talking about the momentum of the electrons and the protons. They're the things that have to go from point A to point B. They're the things that have to move. And we're just arguing about what's moving them. But the fact that they're the things that have to be pushed or pulled or manipulated, that we should all agree on.
You're putting a dot to represent the point. Point is a concept. It's a location. And so you put a dot there to signify, well, that's the location. The center of mass of the elephant or whatever, right? Okay, so what's the issue? These are the problems.
Yes, there's nothing wrong with that either. There's nothing wrong with pixelating the image and saying we know it's made out of little dots, and we know that each of the dots is doing their own thing. And by doing their own thing, it creates the image that we see and whatever. So, I mean, there's nothing wrong with understanding that that's how you dissect the object, is to dissect it in terms of understanding it as little pieces, little bits of space. And each little bit of space has something different happening in it.
The problem is, the first one is the mechanisms. They have several mechanisms for gravity using particles. Okay, we're looking at particles here, and they're all Ptolemaic, they're all irrational. And they know it, and that's why they...
So again, if I said all rope theories are irrational, I didn't prove it, I didn't demonstrate by showing your theory and showing how it's irrational, which I can do, and I think I have done, but you're not doing that to me. You're just insulting me and saying somehow I haven't made the argument. You haven't countered any of my arguments. You're just making a proclamation that somehow you, as the authority, have analyzed all particle theories and decide they all fail. Fuck you, you didn't do that.
They claim that they don't know how...
Why don't you just say, to my knowledge? Just say, to my knowledge, all particle theories fail. But you don't say that. You say there's something histemic. No, there's nothing histemic. There's nothing that can't be explained. You just don't care to hear the explanation, or you just are pretending you haven't heard it.
How gravity works, at least here at the quantum level, here on Earth. Out there, they claim they do know, and that's another story. But I'm talking about here in our little world where we can verify things and so on, right? They say they can't verify, they can't prove to you or even simulate for you the mechanism of gravity. So quantum doesn't have a gravitational theory. That's what string theory is trying to do, is trying to merge quantum and general relativity.
They don't have a theory for any motion, okay? They don't have a theory for the mechanism. That's why I call it a virtual photon, okay? They have a description of what magnets do, but they don't have a description of where the energy comes from. And neither does Ken Wheeler or anybody, or you. None of you have an explanation for where the energy comes from. You don't account for it. You just say it has some property where it's doing something. It's pulling on the rope. It's doing something. And you don't account for where it got the energy to do that thing. So none of your theories account for where the energy comes from. And the only source I think that's rational to understand is that, well, it's come from the same place the cosmic background radiation is coming from. It's coming from the outside in. You're seeing the reflection. Matter is a reflection. Its motion is a reflection of what the field is doing. It's not the source of the light. It's reflecting the light. It's reflecting the pressure.
So that you are able to fit quantum within relativity equations, again, the descriptions only, so that somehow we get this settled, this break between these two grand theories, we settle the issue of gravity. That's what string theory is all about. String theory is trying to solve gravity, okay? That's what nobody can...
Well, anyway, it's obviously just as dopey as rope theory, though, because it's just creating rubber bands. So it's just saying that there's a special little thing called a string, and it can vibrate this way, and it can do this, and it can do that. It's giving it all kinds of magical properties that come from nowhere. So again, it's just bullshit. It's just saying rubber bands are made of rubber bands. That's all it's doing. It's not providing any insight into function or mechanism. And again, it's not accounting for where the energy comes from. The pressure. You have to pressurize the system before you can change pressure in locations. You have to start with pressure before you can have half the pressure here and twice as much pressure there, and before you can moderate it, before you can unbalance it. You have to have a balance before you can unbalance it.
And explain to that, because again, it's a pull force. You can't do that with particles. So the mechanisms, as you see there, are all irrational. That's the first thing I'm going to show today. The other one is,
You're not going to show it. You're just going to say it. You're not going to show it.
Particles cannot explain direction. And I can just give you a little analogy or a little experiment that you can do for yourself. And it goes something like this. Take a chair in your living room, okay? Take a chair and push it towards the wall at the opposite side of the room. Okay? Push it. And you'll see that the chair will go in all directions. Okay? You can't send it straight. You can't get...
So this is not true. So it just depends on the friction. What side of the chair the friction is on. So the forward legs have the friction, quite obviously. The direction you're going, there's going to be more friction on the forward legs. So if you push the chair by pushing the forward legs into the rug or the floor, then obviously you're going to create more noise in the direction. You're going to break the steering. It's like the front wheels versus the back wheels. But that's all you've changed. So by saying, I'm pulling it, therefore it's much more efficient by nature. No, it's not by nature. It's just that you're now taking the friction off the front wheels, and that's all you've done. All you've done is change where the friction is. So again, bogus bullshit. And again, it has nothing to do with the physics in the sense that there's no argument here about a frictioned rug. I'm certainly not proposing that photons or energy or force is pushing objects on a rug. Okay, push them on a nicely waxed floor and they'll go perfectly straight. Get rid of all the friction, push them on an air bed, and they'll go really nice and straight. An air cushion of air. So this is just bullshit.
A fixed direction. Now get on the other side, on the side where you were pushing the chair towards, right? Tie a rope to it and pull on it as straight as you can. And you'll see that it'll come straight at you. It won't go to the sides in general. You have a much easier time of having rectilinear travel on the chair when you pull than when you try to push. When you push, it goes in all directions. Pulling is always straight.
So again, just an insipidly distant analogy, just not even close to the circumstances you could honestly argue would be anyone's argument. Nobody, I don't think, has a theory of particles where they're saying there's carpeting and we're pushing particles against the grain of the carpet.
Keep that in mind. That's something that particle theorists have never discovered, never harped upon it. I think they don't have the mentality to see that because it destroys their proposal, and so they would rather stay away from those.
So he thinks that's a decisive hit, like oh, I just cruise missiled your hideout and I blew you up. Yeah, not even close. It's a silly argument, insipid. you barely even puffed at the the hideout.
Images, and so just keep that in mind. Pulling, whether you pull like when you're in the second floor and you're pulling a couch or something from your yard. Well, if you pull it with a rope, it'll go pretty much straight. You can realize that if you're careful, it goes pretty much straight along the rope. In fact, if you have a pulley, right?
Yeah, well, whatever. This is way too much of the same bad argument over and over again. So jump ahead a little, but we'll call it quits pretty soon. I think we've gotten to the arguments that have any meaning at all.
But trying to push it, it'll go in different ways. Just keep that in mind. That's just intuition, right?
Well, then why don't they pull torpedoes, right, in the ocean, right? Why don't they shoot a rope to the boat and then pull on the rope to get the torpedo to hit the boat? I mean, come on. Bullshit.
So direction's going to be a problem. The other one, how gravity goes through things while pushing them. Okay? Remember, gravity balls, whatever they are, ether balls, little particles, little beads, whatever you think of as gravity particles. If you're going to simulate gravity with particles, well, you're going to run into this problem of the fact that gravity has to go through things and at the same time push them. That's very hard to do. That's where you're going to run into trouble.
So that's where he just he's responding to a comment and he totally ignores the comment. The comment basically pointed out how it's the nuclear bits in the atom that are getting moved, and that the atom, by most people's understanding, is an arrangement of things in a space. Empty jello, it doesn't really matter. There's things and not things. There's things, space. See, this is where the space counter space thing gets backwards, because the counter space is supposed to be nothing and the space is supposed to be something or something like that. They have it backwards. They use the two words inverse to how I think a logical person might use them based on traditional language. But anyway, so just the idea of something and nothing. So something relevant to the force and something not relevant to the force. So the argument is the particle can hit the little charged bits arranged, but it can't hit the stuff in between the charged bits that are arranged. That's the simple argument, Bill. Okay, and clearly it can be understood that some amount of the force, the stuff you're throwing, doesn't hit anything because there's a lot of empty space. And even if it all hits something, even if all the space is filled, when you have enough atoms, there's some location that there's no straight line through without hitting something. Even if that were true, the force hits and the little bits hit each other. So the force doesn't disappear when it hits something. It goes into it. And it could go into two of them, or it can go into three of them, or it can go into four of them, make all four of them move.
Here. That's one case at least. The other one is gravity travels both ways, because if you're pushing with particles from here, you're also going to push with particles from the other side. Why from only one side? Why would the Earth, the particles out there in the ether, in space, wherever, push you always downwards? Aren't there particles going from the bottom all the way through the Earth?
Right, that's the mass argument. So you just don't get it. That obviously the way it works is that if it's a big object, it blocks lots of force that doesn't hit you, and if it's a small object, it's a little tiny bit of force that doesn't hit you. Okay, but that's the fact. If something moves, again, if an electron moves, it moves because it had to absorb something. Something had to go into the electron, okay, and it did a rebound thing, but the electron changed its direction because it's a battery. It has seats, and it gave back something that hit it maybe a million years ago. An arrow hit it a piece of force hit it maybe a million years ago going this way. It's in the boat. It just gave it back now. A million years later, it gives back that rower when this rower went in. And now the electron has a change. But now the electron's moving into a force. Blah, blah. I've already explained all this. But this is a silly argument to make, that somehow you're accounting for what the basic argument is that there was something heading for something, and it doesn't get there because it's stuck inside something else. And you're just ignoring the fundamental argument that Matter doesn't move for free. It consumes something to move.
Pushing upwards. And again, it's easy to try to explain and say, well, this is the way I explain it. No, don't explain it. Make a movie of it. Illustrate it.
There are illustrations. So there's illustrations from Lesage gravity of this very point. And you're just ignoring those illustrations, and then you're ignoring the fact that there are animations of mock gravity, so you're just ignoring them.
Show me the movie. I want to see the movie, okay? And then we have the issue of shielding and masking, which I'll go on as well in a little while. Okay, so what are the...
So again, the shielding and masking, I don't know exactly what his argument there is. There's no... it's absorption of momentum. So you just follow the momentum. If matter's moving, something acted on it to move it. That is, something exchanged more one way than the other way to move it. That's it. There had to be more swimmers going one direction than swimmers going the other direction, and that's why the boat's moving. It doesn't move any other way. It has to do what the field, the sea of swimmers, tells it to. Alright, so that's probably enough. If anybody has anything else, fine. And some other kind of argument they want to cite. But I think I've accounted for all of the arguments that can be made against particle theory working. It does work. It can explain. And yeah, that's all I can do. So, till the next time and such. And so forth and whatnot. And fuck you, Bill. I mean, I don't mean rude, but you're just being an ass to say you've somehow debunked my particle theory, because you haven't.